Hi guys, it's Mrs. Blake again, and today we're going to talk about stoichiometry part 3, mole to gram and gram to mole conversions. The materials you need for this video are going to be a scientific calculator and a periodic table. In previous videos, we've taken a look at what is stoichiometry, and we've taken a look at this mole to mole conversion using what we call the mole ratio that comes from the balanced equation. And what we said is if you have a balanced equation, you can convert between any two parts of that balanced equation. So if I take a look at the equation in number 1, I have aluminum reacting with oxygen to form aluminum oxide. First step is to always balance the reaction. And so when I take a look at this, I see that I have 2 oxygen over here and 3 oxygen over here. I have to have the same number on both sides, so I know common multiple is 6. And if I put a 3 in front of here, 3 times 2 is 6. And that means I put a 2 in front of here. 2 times 3 is 6. And for aluminum then, that gives me 2 times 2 is 4 that I end with. And if I end with 4, I have to start with 4 pieces of aluminum. But the units that we assign to this are moles. So this literally is going to be 4 moles of aluminum reacting with 3 moles of oxygen. And it's going to produce 2 moles of aluminum oxide. And that mole ratio just compares any two parts of the balanced equation. I know that if I have 2 moles of aluminum oxide, I need 3 moles of oxygen to start. If I have 3 moles of oxygen to start, I need 4 moles of aluminum to react with it to make aluminum oxide. So I can go between any two parts of that balanced equation using that mole ratio. But today, we're going to take a look at expanding beyond moles. This is the basis of all stoichiometry, this mole ratio that allows me to convert between moles of one substance and moles of another using the balanced equation. But unfortunately in lab, we don't usually start with moles. If I start with a solid in lab, we're usually measuring in grams. If I start with a solution in lab, then I'm going to be measuring in milliliters of solution. And if I'm going to start with a gas in lab, then I'm probably going to be measuring milliliters of a gas. So my starting place is not always going to be what I need to be able to do the basic stoichiometry problem. Now for today, we're going to take a look at solids. And if I'm in lab and I'm measuring in solids, I'm going to put it on my balance and I'm going to come up with a mass in grams of my starting substance. So I need a way to be able to convert between that mass to get it to moles so I can do the stoichiometry. And in the same side, I can measure my ending product, but if I measure my ending product of ash that's left over, that's going to be, again, a mass that's measured in grams of my ending product. So we need a way to be able to convert between mass and moles. And the way we do that in chemistry is to use a tool that we know is going to be the molar mass. So the molar mass of A is going to allow me to be able to convert between mass of A and moles of A. And the molar mass of B is going to allow me to be able to convert between moles of B and back into mass of B. So when we take a look at a problem now, we may not be starting with the unit moles. If I don't start with moles, I have to get moles before I can use a balanced equation. And I may not end with moles. It may ask me to find the amount of mass in grams, and then I have to be able to use the molar mass. So let's take a look at a couple of example problems. And if we're taking a look at a couple of example problems, part A says how many moles of aluminum oxide will be formed from 48.2 grams of aluminum. And so the number they give me in my problem always is going to be the place I start in the chemical reaction. Because that mole ratio can go between any two parts, I could absolutely start with how much aluminum oxide I have or want and figure out how much aluminum or how much oxygen I need to start with. But in this case, I am going to be starting with 48.2 grams of aluminum. If I start with 48.2 grams of aluminum, every chemistry problem, I'm trying to get rid of that aluminum. So I can take that unit and put it on the bottom so it can cancel out. But then I can take it back to my chart up here. If I have moles, I can go straight ahead to use my balanced equation. But I don't have moles. And if I don't have moles, then I need to do a step first. So in this case, in this problem, I am going to be starting with the mass in grams. And my first step is going to convert using my molar mass. It is really important to understand that the molar mass of a substance will keep me at the exact same substance. So this is going to switch between grams and moles, but this is always going to be the same chemical formula. So I can switch between grams of aluminum and moles of aluminum, but it is still going to be aluminum. Now, by molar mass, by definition, we say in 1 mole of anything. So this is in 1 mole of anything, which happens to be aluminum. I can use my periodic table to find out that its mass is going to be 26.98 grams of aluminum. And what that allows me to do is to be able to cancel out the unit grams. And now I'm going to be at the unit moles of aluminum. So I have quite literally gone from mass of aluminum to moles of aluminum. And now I can use that balanced equation. So don't treat this as 2 separate problems. Your calculator is more than happy to calculate out 5 numbers or 6 numbers all at one time before you hit equals. Don't calculate right yet. So now I have moles of aluminum on top, and I want to put that moles of aluminum on the bottom because I still want to get rid of it. I don't want aluminum. My question is asking me about aluminum oxide. So when I'm taking a look, I now can use my mole ratio. And that mole ratio is really important that it is a ratio of moles. So it is going to be moles to moles. That's what makes it a mole ratio. But this is where I'm going to go from aluminum to aluminum oxide. So while I have the same formula for mass to moles, once I get to that mole ratio is where I am going to switch parts of my chemical reaction. So I'm going to switch formulas. So I'm going to go from moles of aluminum to moles of aluminum oxide. And these numbers, of course, come from my balanced equation. So I'm going to take the 4 moles of aluminum, and I'm going to take the 2 moles of aluminum oxide, and I'm going to put that in my calculator and see what I come out with. Now to calculate this out, I'm going to take anything on the top times and anything on the bottom divided by. The order really doesn't matter. And when I punch those numbers in my calculator, I'm going to come out with 0.893. And the unit I have left, because moles of aluminum cancels out moles of aluminum, is going to be moles of aluminum oxide. And my question says to find the moles of aluminum oxide. So I have found the number of moles of aluminum oxide. Number 2 in part B of this equation looks exactly the same. So take a second, pause the video, and see what you can do with part B of this equation. So how did you do? One important thing to pay really close attention to. Sometimes in a reaction, they will give us words like oxygen. And if they give me words like oxygen, be careful with your chemical formulas. They give us the chemical formulas in the reaction, and oxygen is O2 because it is diatomic. A frequent mistake would be to give me 16.00, which is the mass of 1 oxygen, when it's really the mass of 2. Since you start with grams, we use the molar mass to turn it into moles. Then I am able to use my mole ratio to find moles of aluminum. Now, if I take a look at a problem then, it's going to be really important to pay attention to what am I starting with and what am I ending with. When I read a question and it tells me that I'm starting with 3.2 moles of hydrogen, it means that, hey, I'm starting here and I can use my mole ratio as my starting point. If I start with moles, I don't care about the molar mass on the starting end. I don't care about the molar mass of H2. Instead, I can go straight to that mole ratio to get moles of my ending product. If I take a look at my units, then this question says how many grams of silver would be required to react with 3.2 moles of hydrogen. So this time, I'm not going to stop at moles. I have to use the molar mass of silver to be able to get it to the mass of silver the problem is asking me about. Units are going to be a really important part, and it's really important to pay attention to what those are. So in this problem, I'm going to start with 3.2 moles of hydrogen. And because I'm already at moles of hydrogen, I don't care about the molar mass of hydrogen. I can go straight to my balanced equation and use the mole ratio for hydrogen. The unit on top always goes on the bottom because I want to get rid of that hydrogen. So I'm going to put moles of H2 on the bottom. And this is a mole ratio, so it's moles to moles. And this problem wants me to go to silver, so this is going to get me to moles of silver. The mole ratio cannot do anything but get you from moles of one thing to moles of another, even if your problem needs to end in grams. So I need to balance my equation, and there's one piece of silver here, but there's two over here. There's two hydrogen, and there's one sulfur and one sulfur. So looks like my equation is balanced. And I know that there's no number in front of hydrogen. Well, there's a 1. And there's a 2 in front of the silver. And that's going to cancel out my moles of hydrogen and leave me with moles of silver. But the problem doesn't ask me to go to moles of silver. It asks me to go to grams. And that requires me to use the molar mass of silver to be able to get it to grams. So I'm going to take this unit. I'm going to put it on the bottom. This time it's moles of silver. And if I'm going from moles to mass, that would put the mass on the top, and it's still silver. And this is going to be the molar mass of silver. The molar mass of silver says that in 1 mole of anything, there are going to be some number of grams on the periodic table for silver, and it's going to be 107.87 grams of silver. I'm going to multiply anything on top. I'm going to divide by anything on the bottom. And I'm going to punch those numbers into my calculator. And I am going to come out with 690. And this time it's going to be grams of silver. So it's going to be really important to take a look at your units and read those units very carefully to determine where you're starting at. So part B is similar to part A. Pause the video, try the problem, and see how you do. So in problem B, now we need to pay really close attention to units. I'm starting with 0.47 moles, and if I start with moles, I can go straight to my balanced equation. So this time I'm going to use my mole ratio between H2S to get to where I want to go to, which is silver. But mole ratio has to be moles to moles. So now it leaves me with moles of silver. But once I have moles of silver, I can use the molar mass of silver to turn it into grams. I multiply across the top and I divide by the bottom, and I should come out with 101 grams of silver. So when I take a look at a problem from now on, I understand that that mole ratio gets me from moles of anything to moles of anything else in the balanced equation. But I sometimes start with mass, and I sometimes end with mass, so I'm going to have to pay very close attention. If I start with mass, I need to use molar mass to get to moles before I can do the stoichiometry using that balanced equation. And if I end with mass, then I need to use the molar mass of that substance. Practice some of these problems and have yourself